Happy Monday. I hope you are doing well. We had a whirlwind, crazy weekend over here. My little turned 9 last Thursday and was in the playoffs for Little League on his birthday to make it further through. And then we went into extra innings in the game on Saturday and had to postpone his birthday party and yada, yada, yada. Why am I sharing this? Because it's just May. It's a wild ride of May and all of those things. So I hope you all are riding the waves of the wild May like we are here. And I thought it would be fun to think about comparisons. Our students, check that, humans love to make comparisons. We do it all the time, whether or not we want to. And not too surprisingly, it's a big part of how we work with data. And the questions our students are drawn to with data and with different things like that, there's often this element of we are making a comparison. So I thought today on the Monday of the wild ride of all the things that is May and the end of the year and all of that, why don't we sort of jam on, like, what kind of comparisons can we make with our graphs across our different learners, across our different age ranges, things like that. And I brought some examples. So we can compare across time. So this is a story map. Love this strategy for, like, it's a great one when you're coming back from, say, summer vacation or the weekend, a long weekend for those of us that will still be in school next week after the long weekend. It's a great way to sort of center, have students jump in. We live time, therefore comparing things over time on the story map is our horizontal axis. Then that can be a great way to get kids graphing about themselves. So we like to compare things across time. This is my story map from my early pandemic experience. It is hard to believe that that was 4 years ago. Okay, now shout out to my dad, because my dad knows that I love data and graphs, and my dad has taken to printing out different graphs and dating them for me as to when he prints them out, which is just like so sweet and lovely and long. But here is a map. I'm trying to make sure you all can see it. So we have a map of the United States, and it is the mean center of the population. So yes, we are looking across space and also time as we go from the 1790s to 2020 by decade across. So here we're looking at a comparison. This is an over time comparison, but it's not a line chart, because we don't always look at our comparisons over time on a line chart. And this is a fun way to combine sort of time and space in two ways that we intuitively use and live through and understand and pull on our sort of understanding of the world, help make these connections across our math learning about data with our science application, or in this context with this data set, maybe our social studies content, right? Data crosses all of our different disciplines. So we can compare across time and also space. We can look at, here was a brochure about bald eagles in New Jersey. Here we are also comparing across time. Anyone who knows me knows that I have lots of opinion about double y-axes. But I bring this one up to share because it is looking at, this is bald eagles in New Jersey, as it totally floored me when we had a pair of nesting bald eagles not too far from my house. And I, as a child of the 80s and 90s, was like, I only thought bald eagles were up in Alaska in the United States and in Montana and like not New Jersey, not highly populated areas. But it was so much fun. This is comparing both the number of active nests by year, as we're going through from 1982 to this graph goes through 2017, and also the number of young. It's really hard to see, but the red stars are the number of young as they are changing over time. So now we're looking at time and two different variables across time. And speaking of two different variables, we can compare across different variables. And yes, many of us often think about scatter plots and things like that. But I want to point out that we can compare across variables in other graph forms as well, right? So here we have a categorical, freshly opened and opened 2 hours ago. Here we have time. Our students love time. We are comparing time from the raisins bob up in the soda and these 2 categories, and we have our data. So we are able to compare the time that the raisins are bobbing and those 2 different sodas, so our 2 variables together. Can we look at this in the good old scatter chart? Yes. Can we look at it in a bar chart that our students love? Yes, with the raw data plotted, right? There's so many different ways we can compare across time. Make comparisons. Here's one without time. Speaking of the good old bar charts that they love. Okay, so here we're looking at AI. Shout out to Dad. That Dad also sent me this one a while ago. And the reason why I wanted to showcase this as a way that we're making comparisons is because we're comparing across 2 different categories here. So one, we're comparing the exam results by different AI platforms and the different exams. So we can see in blue kind of how those, we can see the height of the bars, how they performed across these different tests. So test is one of our categorical variables. There are different tests. You are in a different bucket for those different tests. But then we've got a second variable, a second set of categories that we are looking at in this graph. So we are in fact making multiple comparisons when we are looking at these data. And that is, this was GPT-4 compared to GPT 3.5. And so GPT-4 is in green and GPT 3.5 is in blue and different things like that. So then we're also comparing versions. Is this in your curriculum? No, probably not. But are there times when our students are interested in doing multiple comparisons at once? Absolutely. Let's think about we're building cars and we're pushing them down a ramp and we are looking at the distance that it goes based on how many wheels it has or how heavy it has or different categories that we can put it in and things like that. And so this multiple comparisons in one visualization or in one question that we have often happens for our students. So we often get in a space of, we're going to compare A to B, black to white, X to Y on our scatter plots. But rarely is it that simple. And by that, I mean, rarely do our students ask questions that are that simple and have that few pieces going on. And sometimes they do. And shout out to our little learners, our younger learners, and all of you who help our younger learners, right? Here was my son's work from a couple years ago, looking at, who in the class and which favorite pet they had. So absolutely, when our students are younger, they are asking sort of more simple questions. Though they also like to add extra variables in. I'm just saying, living with 2 littles at the moment. And we make some pretty simple graphs to make those comparisons. But pretty quickly, our students are moving through and they are making line plots or dot plots, depending on what subject area and grade level you're at, of this kind of graphic to make some comparisons across 2 different treatments of an investigation that they are running. Or we see out in the real world where we're like, the bald eagles are coming back. We should both know how many nests there are and how many young are in those nests to really track how the bald eagles are doing here in our state. Different things like that. Or our population moves over time. And yes, we can read about that in prose, but we can also visualize that in time. So we ask a wide range of comparison questions as humans, and there are a wide range of ways that we can visualize those comparisons for our learners. Now, I've talked about a variety of different graph types. If you are wanting to sort of dive a little bit deeper, get a little bit more about some of these graph types or how to help your students really get them and nail them using Google Sheets or other graphing programs that you might be using, then I highly, highly, highly encourage you to come join us this week. Oh my gosh, this week we're here. It's so exciting. So we are running a variety of different webinars, 4 steps to graph like a pro and transform your teaching. And we know it is med and it is crazy town right now out there. So we are offering the same webinar across 3 different dates. So if you scroll down, you can read through like what we're going to be covering, the different pieces in this free webinar. Let me just scroll to the bottom. So come join us tomorrow at 4 p.m. Pacific or 7 p.m. Eastern. If that time doesn't work for you, don't worry. We'll be at it again on Wednesday, 2:30 Pacific, 5:30 Eastern. And if this week is just a wash and you're just like, Kristen, I can't do it this week, don't worry. We've got you covered. Next Wednesday on the 29th, we'll be at it again at 1 p.m. Pacific and 4 p.m. Eastern. So I will drop the link for this webinar to register for the webinar in the notes for this live. I look forward to seeing you there. Share it out with your colleagues. Just so excited to end the year with a bang and get you these steps on how to make graphing easier, how to make it easier for your students, and all of those different pieces. And it's not going to take too much time. Promise. That's what I'm all about. How can we do this without adding a lot more time to your days and everything else that you are doing, or your summers, or anything else? Thank you for all that you do. Great seeing you. I hope you have a wonderful week. And I hope to see you at one of the upcoming webinars.